Gauss theorem. We are going to study Gauss theorem, but prior to that, we'll know what's flux, electric flux. When Michael Faraday introduced the idea of electric line of force, he told at the same time that 1 Coulomb charge can produce 1 upon epsilon naught electric lines of force. This will come out to be about 10 to the power 11. So let's remember that 1 Coulomb charge always can produce up to 10 to the power 11 electric lines of force. What's electric flux? To know electric flux that's represented by the letter phi, we should know what's the surface area. You see, surface area is always considered a vector quantity. For example, my palm, this one, it's a area vector. Area might be this way. You can calculate the boundary or periphery of this object and you can find out the area. But the surface area means simply a vector that is pointing normally outward. If you consider the board here, its area, surface area vector would be normally outward. So, whenever you consider area vector, surface area vector, that's taken as normally outward. Now, what will be electric flux? There is some surface, maybe it's a square type, rectangular type, and you consider one particular edge. Its area vector is going to be like this, normally outward. For this floor edge, surface area vector would be normally upward, vertically upward. For the ceiling, that would be vertically downward. Here the area vector is this way, and if the electric is like this, electric field, angle between the two suppose is equal to theta. In that case, the electric flux would be given by E A cos theta. Or in vector form, you can write this as E dot A. At the same time, you can take the integral formula as well. You see, flux may be given as integral E dA, but this is going to be surface integral. When you say surface integral, simply means that the limit would be taken according to the surface. The unit of this electric flux is going to be volt upon meter for electric field, meter square for area, it gets cancelled. The unit of electric flux is volt meter. So, we have known two things, what's flux and how it is based on number of electric lines of force. Now, you can choose what is the meaning of Gauss theorem. Gauss theorem. Gauss theorem says whenever within a closed surface the total charge is Q. I told you 1 Coulomb charge produces electric lines of force 1 upon epsilon naught. If there is charge Q, obviously it will produce the electric lines of force this much. Means 1 upon epsilon naught multiplied by Q. So, what is the net flux? What is flux? Mathematically, you could say it is the number of electric lines of force simply, but that would be given by integral formula, integral EdA, or you can say the vector product, dot product of two vectors E and A. This is Gauss theorem. To interpret this, you can say the total electric flux from any closed surface is given by the ratio of charge enclosed within it and epsilon naught. So, overall this is written in this form also. Here you see we have said Q enclosed. That means the charge enclosed within the surface. I have told you the formula for flux, how this angle is calculated, the integral formula. Now we would consider one cylinder within the electric field and the field that is uniform. Say it's E, electric field. Here, this way. Here also, electric field would be from left to right as we have chosen. But the area vector is going to be normally outward, area vector. Here also, it's going to be normally outward. Angle between the two here is 0. And here the angle is 180 degree. Cos theta here would be -1, this would be +1. Obviously, the flux should be positive here because it involves cos theta. Here the flux would be negative. What's the angle between area vector and E? See, area vector, E is left to right. This angle is going to be 90 degree, cos 90, 0. So, flux here is equal to 0. You got the values of flux at all the three places as written here: positive when the lines going outward, negative when the lines are entering, and 0 when the lines are tangential. So, whenever the electric field is tangential to the surface, flux is going to be completely 0. This is covered. This theorem is always applicable to Gaussian surface. What's Gaussian surface? It's a purely imaginary, it doesn't exist. You have to suppose it. For example, if you consider one line charge, cylindrical charge this way, then in that case we might consider another big cylinder around it that would be considered as Gaussian surface. It might have any shape, but normally we prefer only those shapes which can assign symmetrical distribution of charge like a sphere, like cylinder, ellipse. So, whenever some symmetry is there, it is better to apply this Gaussian theorem. One more example is say sphere. Some charge is placed over here. Say it's a Q. Somebody asks what is the flux coming out of the sphere? Answer would be no flux because this charge is not within the sphere. When the charge is outside the sphere, obviously the flux would be 0. One more thing, one more precaution regarding this theorem is that within the surface, you need not bother about the geometry of the charges, how they are distributed within the surface. It's not material. Simply, we have to take the algebraic sum. For example, I consider here 3 charges plus Q1 plus Q3 and minus Q2. In that case, what we'll do, we'll take the algebraic sum of all the 3 charges. It's going to be, so for the purpose of finding the flux coming out of the surface, or you might say for the purpose of using Gaussian theorem, we need only to find the total algebraic sum of the charges. Then one more thing that's very interesting, if you consider a cube, for the cube we have different positions for the charge to be placed. This is the cube and we might suppose different position of the charges. Here it's a cube having 12 sides, 6 edges, 8 corners. If we consider charge at the center of the cube, within the cube at its center, the total flux coming out will be Q upon epsilon naught. Now, this is very interesting if you consider one charge q at one edge of the cube. Suppose this is the edge of the cube. This is obviously going to be square type. If you put the charge at the middle of this face, at the middle of midpoint of one face, half of the flux is going one side and half of the flux will enter through the face. That means this entire cube is going to have only half of the total flux given by this charge. So in that case, if you are putting the charge at the middle point of the face, total flux coming out will be q upon 2 epsilon naught. Similarly, you might choose at corner and at the middle of this side. If you choose at corner, it's going to be, it's given here, q upon 8 epsilon naught, and if you choose center of side, it's going to be q upon 4 epsilon naught.